So for today's notes, I'm going to talk about the centroid, midsegment, and proportionality theorem. Basically, these are just different properties of triangles. So my essential question is, how do I solve different relationships inside of, let's read triangles plural. Okay. So centroids, they are made from medians. Recall, a median is the line across from an angle to the midpoint across from it. So what a median does is it splits the line in two equal parts and then connects back to the vertex on the other side of the triangle. A centroid is found where all three of those meet up, and this point P in the middle is, so the short part is 1 part and the long part is 2. So it's a total length of 3 parts. So AP over PE has a 2-to-1 ratio. Okay. On example 1, it tells me SQ is 8 and wants me to find QW and SW. So I know SQ to QW has a 2-to-1 ratio. So if I knew that, and I actually know what SQ is, I can replace SQ with 8. So I have 8, and I'm going to, oops, how do I erase? Not like that. Oh, no. Okay, so I'm going to use X for my QW, because I don't know what that is. I'm going to set it equal to 2 over 1. I cross multiply, so I have 8 times 1 equals, and then over here I have 2 times X. 8 times 1 is 8. 2x, divide both sides by 2, and I get x equals 4. So that is QW equals 4. And then SW is the entire length of these. So if this is 4, 8 plus 4 is 12. Why are you on here? Nope, it's on the erase. Okay. So this one is telling me Q is the centroid. Q is a centroid. VQ, so this piece right here is 5. I want to find RQ and RV. So my proportion here is RQ to QV is 2-to-1. I replace RQ with X. What am I doing? And QV with 5. I cross multiply. I get 10 equals X. So that was RQ. And then I want to do the same thing I did on the other one to find the entire length. This was 10, so I add 10 and 5, which gives me 15 for RV. A midsegment of a triangle is a line that splits, or that connects 2 midpoints from the sides together. So this one has all 3 drawn in it, but you can have it anywhere on the triangle. There's 3 midsegments. Typically, you'll see it with 1 drawn on, and the midsegment will always be parallel to the third side and half the length of it. So this is parallel. These are the parallel triangles, in case you're wondering what I was drawing. And then this one is, no, it's not what I want. Oh. Okay, so on here, AC, nope, MP to AC is 1/2. So on 3, this one is telling me it's a midsegment. Because it's a midsegment, it's splitting these into 2 equal parts. AC is being split into 2 parts. So this one, I just set it equal to X, and I'm done. The tricky part is when I'm looking at the midsegment itself, and comparing it to its parallel line. Okay. So this one is having me compare the midsegment to its parallel line. So remember, our proportion is AB to XZ is 2:1. And then I replace what AB is and XZ is. So I have 3x minus 1 over 34 equals 2 over 1. I cross multiply, so I get 3x minus 1 times 1. And then I get on my other side 34 times 2. I distribute on this one, it just gives me back 3x minus 1. On the other side, I get 68 when I multiply. I add 1 to both sides. I get 3x equals 69. Divide both sides by 3. And I get x equals 23. This one is showing me that IH is my midsegment of triangle ABC. So this one, the proportion is IH over C. Oh, it's not C. Oh. CA is 1/2. So I am going to replace IH with what it has. So it has 30 plus 2x over x plus 24 equals 1/2. I cross multiply, so I have 30 times 2x, or 30 plus 2x times 2 equals, this one is x plus 24 times 1. So I distribute. 30 times 2 is 60. 2x times 2 is 4x. And over here, when I distribute, it just gives me back the same. So I have x plus 24. I want to get all my x's on the same side, so I'm going to subtract this x over. I have 60 plus 3x equals 24. Then I want to subtract 60 on both sides. I get 3x equals negative 36. And I divide both sides by 3. And I get x equals negative 12. Okay. The next thing I need to talk about is the triangle proportionality theorem. It states that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the two sides proportionally. So what that's saying is if this is a parallel line to this line, the ratio between this and this side, so this piece to this side, is the same as from here to here. Okay. So I'm asked to prove this. I am given this triangle. I'm told that the two lines are parallel. And I need to prove that RT, so the ratio from here to here, and compared to here, is the same from here to here compared to here. Okay. So my first step is to write my givens. So TU is parallel to QS. Then I know that this angle is congruent to itself by the reflexive property. I can tell that angle Q and angle RTU are congruent because they're corresponding angles, because QS and TU were parallel. Then I can tell that the two triangles RTU and RQS are similar because they have angle-angle similarity. I proved two angles are similar. Then, because I know they're similar, I know that the ratio of QR to TR is the same as SR to UR. So, this one actually needs to be on my picture. Okay. Then what I can do is I can also write segment additions. So QR equals QT plus TR, and SR equals SU plus UR by the segment addition postulate. Okay. Then with substitution, so what I did was I took this and I plugged in right there. And I took this and I plugged in right there. I just changed that equation. Next thing I did was I split these up into two fractions, because when I have addition on top and the same denominator, or one denominator on the bottom, I can split it up so each top piece gets its own denominator. Notice this piece and this piece are divided by themselves, so that turns into 1 by simplifying. Once I simplify, I can get rid of the 1's by subtraction. So if I subtracted 1 on both sides, they would cancel out. Then I have QT over TR equals SU over UR. Oops. Which is the same because, did I skip a step? Yeah, it's the same because I still have the same pieces. So I have QT matching up to SU. They're just labeled different. And TR matching up to UR. Okay. On 7, I want to solve for x, so I know my sides are proportional. What I'm going to do is I'm going to have 15 over 5, so I went for my right side, and I'm going to set it up to the left side, so my longer side was 9 over w. I said solve for x. And I cross multiply, I get 15w equals 9 times 5. 9 looks terrible. Okay, 15w equals 45. Divide by 45 on both sides. And I get w equals, you know what? Nope. Don't divide by 45 on both sides. Divide by 15 to get w alone on both sides. Then you get w equals